We do slope.
Yeah.
Slope is a derivative.
The line.
Okay? So when we're moving forward, that's a derivative. That's acceleration. If we're going backwards to position, that's an antiderivative. So from 3 to 9
is 6.
It would be 2.7. Well, let me do it the right way. I don't like the way they do it. 1.3 minus 2.7 over 9 minus 3. So that turns out to be negative 0.233 meters per second squared.
That's all.
Well, and then the second question says, for what value of t in the table
None.
is this average acceleration approximately equal to b prime of t?
None.
Well, wouldn't it have to
It would be approximately v prime of 6 by the mean value theorem. Because the mean value theorem says that there should be some point in between those two that is equal to the slope of the others. It's just we're not going to get exact. By MVT should be approximately this average acceleration. Now we have a free response question together.
That's password.
Okay, again, well, this is 2001. This was not a calculated problem.
That's a long time ago.
We weren't born yet. So when people born in 2001 are in their 20s. Yeah, they are 20s. Yeah.
Okay.
Imagine being born in 2000.
A car traveling on a straight road with velocity 55 seconds at time equals 0. That's important. That's an initial condition. It's basically telling us that
It starts at 55.
v of 0 is 55. For 0 to 18 seconds, the car's acceleration, so this is acceleration,
How is 55 at 0?
is feet per second squared. What?
I'm trying to figure nothing.
Because it's
Being
already moving when it started.
Yeah, when you take your car like at a break, it starts moving.
No, it'd be like.
Okay, this is not velocity, this is acceleration.
Correct. Yeah, but we're talking about the V of 0. I'm trying to be logical. We're doing
Oh.
math. Like, why is it 55? That makes no sense.
Because you are already.
Whenever
moving when
we
they started.
started timing.
Okay.
If you're on an interstate or something.
Okay.
Yeah, it's already in motion.
My brain was trying to
Good question.
logic.
The car's acceleration, a of t, is in feet per second squared. The piecewise linear function defined by the graph above. Okay. A. Is the velocity of the car increasing at t equals 2 seconds? Why or why not?
No.
Okay.
Yes.
Let's think about velocity
Yes.
increasing.
Yes, because it's above.
So velocity increasing is really talking about what? Yeah, it's talking about acceleration. Because if you're trying to figure out if velocity is increasing or decreasing, that's acceleration. So if the velocity of the car at t equals 2 seconds, we see it's at 15. That's positive. So yes, it is increasing. So since v prime of 2 equals a of 2, that's
No, I just spelled sense almost like science.
okay. And a of 2 equals 15, then the velocity is increasing at t equals 2. You can say because a of 2 is greater than 0.
Oh, so this is the graph of acceleration.
Yes. Mark fast and look for it.
Yeah, that's a good thing to circle.
No wonder I was so confused.
B, at what time in the interval 0 to 18, other than t equals 0, is the velocity of the car 55 feet per second, and why? Okay, so
Maybe like
other than 0, so
8.
is that here?
18.
That's at the beginning. 18, okay. Oh, because it says 15. That's
Yeah,
why
10.
you're saying. Okay, so remember that at what time in the interval is the velocity of the car? That this is acceleration, not velocity.
But they're the same place.
That is true, but this is acceleration, not velocity. That's just saying at 18 and at 0, they're both accelerating at the same rate. But it doesn't say that they're both 55. How do you find the velocity given acceleration?
Look at the
Antiderivative. So given a picture, how do you find an antiderivative?
The area from the x-axis.
So the area here I know is more than 55. How do I get it back to 55? Subtract. So what areas would I subtract? How do I know when it? Why would an area be negative?
Because
It's under.
So if I find the area that's equal to this one, then it would be back at the same original speed. 12, yes.
I did say 10.
I said 10.
I mean,
So here's how we could do this, show this.
you just do that. Do the area.
So at time t equals 12, because, so at t equals 12, because from 0 to 12 of a of t dt is how much?
0.
Yes, it's v of 12 minus v of 0, which is indeed 0.
dt.
So there was no, I said v of 12 minus v of 0. You didn't have to put that in. But you can see that those two are the same, so that's why it's 0. Or if you wrote out in word form, because the area under the curve from 0 to 6 is the same as the area from 6 to 12. One's positive, one's negative, it's 0. You could always do it that way too. It's just this is the shortest, most concise way. Okay. C. On the time interval 0 to 18, what is the car's absolute maximum velocity in feet per second? And at what time does it occur? Justify your answer. Okay.
The biggest area?
I mean, that would be like the 6 to 16 range.
Okay, so absolute maximum velocity is like, absolute extrema.
Yeah.
Right?
Yeah.
Extreme value theorem. Those can occur at the beginning, at the end, or at a critical value.
6.
Critical value is at 6. So let's see.
Say 16 though.
It changes
I did
from
6.
positive to negative. Yeah.
So yeah, that's a 0. It changes from positive to negative.
16.
So that's a maximum.
16 would be a minimum.
Correct. Or she was just saying critical values.
Oh, yeah.
Okay, so V of 6, V of 16, yes, okay, but that's a minimum.
Yeah.
Oh,
So
That's what we
we
were
can
discussing.
go ahead and get rid of that one. V of 0
And V of 8.
and V of 18. Okay, V of 0 we know is 55. Okay. V of 18,
Not 55.
yeah, it's going to be less than. you can figure it out for sure. But I know a 0 here is going to be less, more or less, and slightly more here, but it's never going to recover all the way.
Yeah,
So I can go ahead and get rid of that. It's got to be at 6.
fine.
So let's find out what it is at 6. So we would say the antiderivative from 0 to 6 of a of t dt, but the only thing that I haven't included in this was 55, and this is something we haven't talked about yet, but I want to talk about it right now. So we initially, at 0, we started at 55, so I have to include that 55 there.
Because that's the 0.
That's the 0. So this is our initial condition, plus however much more our velocity is.
So as long as it's not negative, it's more.
It should be more, but we got to find out exactly what it is, he said. So 0 to 6 of a of t, I can look at my little picture there, and I can find that area. It's a trapezoid. So the area is 1/2 times the height, which is 15, times 6 plus 2.
6.
Right? Does everybody see that? Okay, 8 times 15 is 120 divided by 2, which is 60. Yep.
Oh.
So 55 plus 60 is 115. Oh, but it's not miles per hour, so it's feet per second. Feet per second. Boom. Yep.
I wonder how many miles
I don't know. We could figure it
That's
out.
a conversion.
But I'm not. Yeah, it's a conversion.
I'm not doing it.
Actually, we're done. We could, but
Wait,
next
we
is
didn't
day
do
58
What
homework.
about D?
D.
Yeah, there's a D.
Is there a D? Oh, poo-poo.
The one that wasn't a D, you had a D answer, and I was like, wait.
I was really excited.
How many feet are in that?
5,280. At what times in the interval 0 to 18, if any, is the car's velocity equal to 0? Justify your answer.
0 to 2 to 18.
The car's velocity. No, that's the acceleration.
Dang.
Okay, so a minimum. Oh, what does it say? The car's velocity equal to 0. Our minimum would occur at 16. Do you agree?
Yes.
Yes.
Because that's where it is at 0 and it goes from negative to positive.
Yes.
So we just find b of 16. It's 115. That's all the way from to, what was it? 6?
Yes.
6. Plus from 6 to 16 of a of t dt.
Maybe that's 12, isn't it?
6 to 16 is 105, by the way, and it's negative because it's below.
It's only 78.
So that's 10, so never.
Never.
Never going to equal 0.
It's only 78 miles per hour.
Oh, is that all it was?
Yeah.
That ain't going too fast.
Only 70.
Only 78, especially if they're on the interstate.
Highways are bad to go.
Shoot.
Is there?
Yeah.
Oh, 70.